Hello again, my fellow Jeti users, and welcome back to my workshop. This video I thought would do something just a slight variation on things. Rather than take you through button by button press, I'll take you through the general setup of what at first appears to be a very daunting model. And it's a 14-channel glider with 8 trailing edge surfaces, plus 2 air brakes, throttle, retract, rudder and elevator, making a total of 14 channels. So there's 10 servos in the wings alone. And I think a lot of people would look at that and think, oh my goodness, how am I going to program up all those flaps and ailerons and mixes and travels? And I'm hoping to show you that it's actually incredibly easy if you get the very basic setup correct and understand what you're doing and what Jeti is doing. And we'll also take a look through how I set up all the telemetry, the alarms, the voice output and stuff, because that might be of interest to you and give you some ideas there. Recently, in talking to quite a few of my fellow flyers at the slopes or the airfield, I've discovered that they're not using the voice output. They're sort of holding the transmitter up and looking at the screen. And there's really no need for that. Everything you need to know, Jeti can speak to you. So you don't have to take your eyes off the model to look at the screen. So that sort of part of this programming may be of interest to you. What is the model? Well, I bought it recently second hand. It's the Tangent Nimbus 4 glider. It's 6 meter span. It had 4 servos in the wings, but just 1 aileron and 1 flap per side. So there were 2 servos driving an aileron and 2 servos driving a flap. And the chap I bought it from thought he'd very cleverly got it all mechanically set up, and he was running each pair of servos on a Y lead. So 2 aileron servos on a Y lead driving 1 aileron, 2 flap servos on a Y lead driving the 1 flap, and then duplicated on the other wing. And he was very proud of how he'd got it all mechanically set up so the servos weren't battling one another. But once I separated the surfaces, you could see that, oh boy, yes, they were battling one another. They were nowhere near mechanically set up. Why did I separate them? Well, the aileron hinge line, roughly halfway along, suddenly sweeps back. So you've got 2 different hinge axes. So trying to rotate one surface on 2 different hinge axes is never a good idea. And I looked up Tangent's instructions online and found that they do actually give a travel for if you've got a 1-piece aileron, or the 2 travels for split ailerons, inner and outer. So I thought, well, that's that. So I got the razor saw out and carefully cut the aileron where the hinge line changes its axis. And I thought, well, why don't we just do the same with the flap? Cut it roughly halfway, midway between the 2 servos. That gets rid of the problem of having to try and get the 2 servos matched so that they're not fighting one another. Plus, it allows us to even more finely step the aileron travel and the flap travel. So obviously you want your outer ailerons, which have the most leverage. They're doing the biggest travel. The next ailerons in have a bit less travel. Then if you had a 1-piece flap, do you have a bit of travel or not? But if it's 2-piece flap, the outer ones can do a bit more travel, and then the inner ones can do very little or no travel at all. Just makes life a lot easier. You've got all those servos. Why use Y leads? You've got the channels to run it. So program it up properly. So there we go. Well, how do we get this thing to work? Okay, we pop in, go into model, basic properties, straightforward. Wing type, 4 flaps, 4 aileron. Jeti's already thought of it for us. And if we look here, we can see the 4 servos. It's got S1, S2, S3, S4. That's your aileron servos. S1 to S4. Left to right, I always labour this point, but I still come across people who haven't understood that this is how it really works. What was it? Multiplex used to do it left, right, left, right. I think JR did it right to left. Jeti does it left to right. Servo 1, Servo 2, Servo 3, Servo 4. Flaps, flap 1, 2, 3, 4. Makes if you get it right, makes life a lot easier. Tail type was normal, of course. Engine count 1, because we've got a throttle here. Couple of air brake servos. In the wings, gear servo 1, and that's the basic settings done. Everything will flow nicely from this. Functions assignment, let's have a look at that. Throttle is assigned straightforward to P4. The air brake is assigned to logic switch 5 because I'm using throttle and air brake on the same stick, the P4 stick. Now, if you have a look through my list of videos, you will find that there are some videos about using throttle and air brake or spoilers on the same stick. And that's what I'm using here. So that as I switch flight modes, in the launch mode, P4 will work as throttle. In landing mode, P4 will work as the air brake, using L5 to operate it. And I've got full safety of throttle cut switches, and because I like the stick forward to be no air brake, which corresponds to high throttle, of course I've used that extra safe setting on both the throttle and the air brake, so that the throttle will not engage the motor throttle, as it were, unless the stick comes all the way back. And similarly, the air brake will not work until I push the stick all the way forward, which is 0 air brake, and then pulling it back will make it work. Flaps, there's nothing assigned there as a control because it will be controlled by the flight mode trim, by the butterfly, things like that, and gear on its little switch. Okay, on to servo assignment. Now, of course, initially Jeti puts it in all nicely. It would do channel 1 would be throttle, channel 2 would be aileron 1, then it go to aileron 2, flap 1, work its way through to aileron 4. I have reassigned them all over the place because in this model I'm using a central box 220 with a couple of RSATs in double path mode. And the central box is aligned sort of left, right in the fuselage. So I've got one bank of sockets on the left side and a bank of sockets on the right hand side. And of course I've got 5 sets of cables coming in on each side from each of the wings. And of course Jeti initially assigning them all along sort of channels 2, 3, 4, 5, 6, 7, 8, etc. put them all on one side of the central box. So I've simply reassigned the channels around so that the servos and cables that are on the left wing, which is things like aileron 1, aileron 2, it's flap 1, flap 2, all come in on the sockets that are on the left side of the central box, and for the right hand wing ones on the right hand side. Why did I do it that way? I could have remapped within the central box itself and said incoming channel 2, which would have been aileron 1, map it to another socket, which is fine, and that works until you take that central box out and put it in another model years to come, forgetting of course that you've remapped it and wondering why everything's all completely screwy. Or just, a couple of weeks down the line you have a faulty servo, you're trying to diagnose it. It tells you here that it's in the far left aileron servo would be channel 2, so you go looking at your central box channel 2, unplug it, but that aileron's still working, and now something else has stopped working. It's bizarre. So I just prefer to do it all here, then it's all nice and clear. But you can remap it in the central box if you wish. Servo setup. Now, as a general rule, I go to servo setup to change things like subtribs and travels last of all. Obviously we go in here to change servo reversing straight away if you need to. But I would tend to change subtrims and travels last, after using a better menu first, such as aileron differential, butterfly, flight mode trim. However, there are circumstances where you go straight to servo setup and set things like travels, and they do that for things like the retract, the rudder, the elevator, the air brake. So let's have a quick look in there. We start scrolling through the elevator. You can see I've set the travels there, because there's no need to do it. You could do it in something like function curve or asymmetric dual rates, but why? That starts to make it more complicated. Done in here is nice and easy and straightforward. The retract servo, again, there's nothing's mixed to it, nothing else affects it. It's nice and straightforward to set it here. But you'll notice for all my wing trailing edge servos, so that's the ailerons and flaps, subtrim is at 0 and the travel values are 100%, because I've been around every trailing edge surface adjusting the linkages so that the surfaces sit exactly neutral with the servo at the neutral point. Air brake, they're a good one for setting your max positive and negative travels to get them seated and locked nicely. And air brake 2, which is the one on the right wing, because following Jeti's convention, air brake 1 would be on the left wing. So air brake 2, what I do is get them to match their travels at fully closed and fully open by using the normal servo travel, max positive, max negative. But air brakes can be very floppy devices. Their mechanism's not easy to adjust deep inside the wing. And so you can find that halfway they've got quite different travels, or they're sort of, one cracks open several millimeters and the other one hasn't quite come out of the wing yet. And that's where a servo balancer can be very effective. And so what I've done here is I treat the left-hand wing as the master one that I'm going to follow, and the right-hand wing as the one that has to match to the left-hand wing. So I don't do any balancing adjustments on the left-hand one. I've set up its max positive and negative, so it's fully open, fully shut. Done the same for this one. But we come in here into the servo balancer, and to do this I switched off the auto. And the reason for that is if you leave auto on and you adjust points in the curve, it'll smooth it. So you can see I've taken the center point here way down. With auto on, it would have started a nice smooth curve down, and it could have adjusted the end points. It would have adjusted lots of points, and I don't want that. So it just with auto switched off, it just drags down the point that you're adjusting. And I found that these points here needed adjusting as well. So that's why you've got a sort of inbounds curve. But now the brakes move together. So at any point of moving the P4 stick, both brakes are open by the same amount. Okay, we move on from there into the flight modes. I've set 5 flight modes for this. There they are, pretty standard. Thermal speed and cruise on my little 3-position switch on the left-hand side. And I've got a launch mode and a landing mode set on another 3-position switch, this one here, where the center point of the 3-position switch does nothing. And launch and land mode are above the SA switch for the other modes, so that they will take priority. So it doesn't matter which of these modes I'm in. For instance, I'll switch to thermal mode. There's thermal mode. But if I switch on launch mode, it will go to launch. So both launch and thermal are on. If you're not sure how this works, see my video on managing flight modes. Okay, and I've set a relevant voice file for each one so that I know as I've switched it on. If I turn up the volume,
thermal, cruise, speed, cruise.
And there's double voice files going on for launch and land. We'll come to it later, but this is what happens.
Launch.
Pull throttle stick back.
Cruise. Landing.
Push throttle stick forward.
Cruise.
There you go. Just to remind me, if you're coming into land, you put it to landing mode, you've got to push that throttle stick all the way forward before the air brakes will start to engage. Similarly, if I suddenly switch it back to launch mode because I've made a right mess of the approach and I need to power up and go around, there's no point pushing it to launch mode and pushing the throttle stick forward because nothing's going to happen. Hence the reminder, pull that throttle stick back. You've got to get it to re-engage. Okay. On to digital trims. And you can see I've set the elevator to separate. The others are all as global. And the reason for that is that in things like thermal and cruise and launch modes, I can set up the correct attitude just by using the trim buttons. Flight mode trim, in here, ailerons, servo 1, 2, 3 and 4, so that's outer left, inner left aileron, inner right aileron, outer right aileron. You can see that in cruise mode nothing happens, but if I go speed mode, you get a little bit of aileron trim for that. And if I go to launch, thermal mode, a bit more there. And there, I don't think there's anything in the cruise or launch mode. No, there isn't. And similarly, if we come down to flaps, you can see again, speed mode, a bit of flap, and thermal mode, a bit of flap. And these were done, as you can see, the numbers are different. So you'd switch off symmetry to allow you to adjust each surface to get exactly the correct travel that you want. The no dual rates or expo. Function curves, I've done one thing in here, and that is in the air brake. You take a look at its curve. It's left as global. I don't have to try switching function curves on and off in the different flight trims, even though the air brakes will only work in landing mode. And the reason is because of the way the logic switches are set up, air brake will only work when the landing mode switch is in the landing mode position. In every other position, air brakes won't work. So I just don't need to do any other changes in here. If you remember back to the original setup of the model, in functions assignment, the air brake was assigned to logic switch 5. So unless logic switch 5 goes active, air brakes aren't going to work, which is why I don't need to do anything in the dual rates or function curves to separate them out in flight modes. But I've set it to a 3-point curve. The reason being, I can take the center point, which starts here, and shift it over here. And the reason for that is if we go into landing mode, and I now move the stick, there we go. That's air brakes closed. There's opening the air brakes open. Half of the stick travel, in other words, getting to this point here, was being taken up just unlocking the brakes and just about starting to crack them open. And I thought, well, I don't want that. You know, if you start to try and gently ease the brakes open, you don't want to have to come back half the stick, and then how open they are is only available on the remaining half stick. So by shifting that point over there, it means that I've only got to come back quarter stick, and the brakes will have passed their unlocking point and just be starting to open. So it now gives me 3/4 of the stick travel to actually control just how far the brakes are open. And that's the simple reason behind that. Right, what about getting all those ailerons and flaps to work as ailerons? Well, it's simple. We go into aileron differential. There's no control needed to be set because it's the ailerons, no adjustment. Mode is global because I've got no reason to change the travels in different flight modes until maybe flight testing will show something different. And initially what I did was change all of these down to 0%. With symmetry on, all you have to do is turn that one down to 0 and the whole line goes to 0. Come down, change that down to 0 and the whole line will go to 0. Then you can switch symmetry off. Now the reason I change it to all down to 0 means that I can move the stick to full travel without worrying that the servos are going to move and maybe reach a mechanical limit and bind or struggle. So what I can do is concentrate on servo 1 first of all, which is the far left hand aileron servo, push the stick hard over and start winding the numbers up until I've got the travel up and down that I want. And I got the travel from Tangent's website, so there's sort of differential required on that servo. And because the servo next to it was not moving because it was set as 0, it meant I could measure the travel of this servo holding the ruler against this one. So the root of this servo against the end of this, or the root of this aileron against this aileron, This one's not moving, means it's very easy to measure that travel. Come out to this wing, do the same for that one. You can measure the root of that aileron versus the root of that aileron, which isn't moving. Get your travels set very nicely. Amazingly, they came out the same as this one. Lo and behold, lovely. And then all you do is come to this one. Again, you can measure the root of that one versus the flap that's sitting next to it, which isn't moving. Set your travels up and down, come over here, do the same thing there. And there, lo and behold, is all your aileron travels set very quickly, very easily, no binding, no hassles. Butterfly flaps. Okay, change this to separate mode, and in where are we? Landing mode. I've set a control P6, which is the slider on the left hand side, because that's what I like to use as my butterfly control for these. Remember, I'm using P4 stick for the air brakes themselves. If I go into any other flight mode, so there's the flight mode, there's control. No, we're in landing mode. Put it back to cruise. In any flight mode other than landing, there is no control. So only when we're in landing does P6 come on. Okay, and similarly, there is no value for ailerons in any other, or flaps in any of the other flight modes. Only when we go to landing mode do we have a value there, and that sets the maximum travel value for control P6. So there'll be nothing when P6 is at nothing, and then as P6 goes to its maximum, those values will be what appears at the servo. Okay, and elevator adjustment, tangents instructions give you a suggested elevator trim with butterfly. So I've set up that in the elevator adjustment at the lower end of what tangents say. It'll at least get things started properly. And as I've explained in other videos, once again, I've gone to a 3-point curve and I've dragged the center point that way a little bit, because as you apply butterfly, the initial stage of the flap going down gives a lot of extra lift, and the later stages don't add any more lift, just drag, which is what really you're trying to achieve. So most of the ballooning, and therefore most of the elevator trim compensation, tends to be in the very early stages. So there we go. That's the early stage of me moving the lever. So that's the direction I drag it. So I get proportionally more elevator trim there than in the rest of it. And that's the reasoning behind that. And there is the butterfly setup for the whole thing. No snap rolls, free mixes. You're probably thinking, gosh, a model like this must have loads of free mixes. Stand by for a surprise. No, there is only one. Ailerons to flaps. Let's have a look in there. So aileron to flaps, again, it's global. At this stage, I see no reason to have it different in different flight modes. Master value 100%. When you're thinking, crikey, it's a lot to do. But you come down here, and this is where you actually set the individual travels per servo. Because we've set it to 100%, we can start with all these mix outputs set to 0, rather than the 100% they default to. So set them all to 0. Now, this isn't the aileron servos, this is mix output. It's aileron to flap mixing, so flap is the output. So this is flap servo 1, flap servo 2, which is the left wing, outer flap, left wing, inner flap, then right wing, inner flap, right wing, outer flap. And you just go through setting your mix inputs to what you want in each one individually. So what I did with the inner flaps was I thought, well, I don't want any down travel at all. So set them to 0, give them a little bit of up travel, and then the outer flaps will give them a little bit of down travel and a bit more up travel. And the result being that if you apply, say, full left aileron and look along the wing from the root outwards, the 4 surfaces, there's a little bit of up travel, a bit more up travel, a bit more up travel, and a bit more up travel as you go from the flap out to the outermost aileron. And when you go down, the inner flap has no down, the second flap has the tiniest bit of down, The first aileron has a little bit of down, and the last aileron has just a tiny bit more down. There you go. That's all the aileron and flap travels set up. Marvellously simple, really. Okie doke. Turns the page of my little notes here. Okay, right, let's look at the other options. Throttle cut is set to logic switch 2. This is my standard throttle cut switch. It's the locking toggle switch, and that's the one I would normally use for the throttle cut, but I want the throttle only to work when we go into launch mode. So throttle cut switch is set to logic switch 2. You'll be thinking, what's that? If you have a look at my video on how to set the extra safe throttle cut, it explains what's been going on here. But I'll show you in a minute an extra logic switch so that both my standard throttle cut and the launch mode work together. Both of them have to be in the run position. Why don't I just rely on it being in launch mode? Well, that's not a locking toggle. I could have put it into launch mode and things that work. So I like to have both my standard switch, the one I will always go to. In a hurry, my brain will go to this one. So, you know, after landing, if I've somehow managed to leave it in launch mode, knock it into launch mode or whatever, if this one is off, that throttle is not going to work. Stick switches setup. I always go through this for my models. So if we have a look at it, this determines what happens when you switch the transmitter on. It will go through all the sticks and switches and see if there's any settings here that must be enacted on the switches before it will switch on. So we run through it. Here we go. P4, the throttle should be at the bottom position. P6, that's my butterfly, needs to be in the off position. It says top on, that's the switch itself, but that is where the butterfly is off. More importantly, things like SB, the retract, needs to be in the wheels down position, so that when I switch on, it doesn't suddenly hoik the wheel up and then break the doors off. And if we run through things like SD, needs to be at center. That's the switch that switches between launch and landing mode. So being at center would guarantee that the motor should be off. And E, switch E, must be in that position there. So it guarantees that my motor just isn't going to run. Okie dokie. Logical switches. There's quite a few of these now. Okay, throttle 1, throttle 2, spoiler 1, 2 and 3 are exactly, or pretty much exactly as per my other videos about using throttle and spoiler or air brake on the same lever. So if you're wondering how those work, go and have a look at them. These are how you make sure that they will not work until the throttle is pulled all the way back, or the air brake, as it were, is pushed all the way forward, and then they'll engage. So they don't suddenly pop into half-life. There's one additional logic switch here, which I've called throttle 3, and that is SD, which is my flight mode switch for launch and land, and SE, which is my standard throttle cut switch. It means that both of them must be in the run position for logic switch 3 to come on. Logic switch 6 to come on, I should say, not logic switch 3. And I then used that in throttle 1. See, normally it would be P4 with the SE switch, your throttle cut switch, but I wanted both of them to have to be in the run position. So what it does is take P4 and both of these in the run condition before it'll switch on. Okay. Sounds on event. There's a couple of extra ones here, which I demonstrated earlier. When I move into launch mode or landing mode, I'd like the transmitter to remind me not only that, you know, we've gone into that mode, but that I need to move the stick either all the way forward or all the way back in order for it to engage. And normally at this point I think, well, I need a new sound file, so I go off to the RC-Thoughts website and use the text-to-speech create a sound file, bring the PC out to the or laptop out to the workshop, plug it to the transmitter, download the file. There we are. I thought, stuff it, I'm in a hurry. So I used the microphone on the 24, which I believe the 12 has as well, just to record myself saying it. Thought that's fine, that'll do. 2 different voices might catch my attention. So I made those voice files, and I've assigned them to the launch and land switch. So if I turn the volume up, you can also see I gave it a delay. And the reason is, when I move the switch into the flight mode screen has been told to speak the flight mode WAV file. So I then put the delay in here so that this will give the flight mode a moment to say which flight mode it's in, and then this will kick in like this.
Launch.
Pull throttle stick back.
Cruise. Landing.
Push throttle stick forward.
Cruise.
There we go. And these ones are just the normal ones I use about the throttle lock itself.
Warning. Throttle lock is off. Throttle lock is on.
Okay. No sound or proportional controls, no telemetry controls, no voice commands, no sequencer. Yes, the accelerometer is used in the timer, but we don't need to do anything to set it up. And so we can come on to timers and sensors. Timers. There is one timer I've made. It's the total flight timer. So how long is this flight going on for? So the initial value is 0, so it'll start at 0 and count up. It's free running, so that once it's started, it will not stop. And if you operate the switch that started it, it's going to keep running. Report type is voice. The switch. Now then, what are we going to use for the switch? We could use, if we come back here, this start here. Start the timer. It'll start the timer running. That would start recording, logging the telemetry data. But I'm afraid from time to time I do forget to start it. I want it to be automatic. How can we be automatic? You think, well, open the throttle to launch the model off its trolley. Yeah, problem there is, what if you're doing testing on the ground, that you open the throttle to make sure that the throttle lock is working. You go into landing mode to check that the air brakes are working properly. All of this time is moving the P4 stick. So we don't want the switch to be the P4 stick. And what we're doing then is using the input control is the actual channel. So if I clear it out and show you that, come down here and use the actual throttle channel, which is throttle 01. Set our switching point. We need it to be in launch.
Launch. Warning. Throttle lock is off.
There. Say the stick needs to be there. Well, it'll say halfway. Press this button to set it, and there we go. Below it it's off, above it it's on. That's good, that's what we want. Which means that on the ground, with the throttle lock in the off position, and not in launch mode, the timer cannot start. So I shall operate the P4 stick. Nothing happens. I'll go into launch mode. Watch that, launch mode. I'll operate P4 stick. Nothing happens. I'll switch on or switch off the throttle cut, so that's in the motor run position, and I'll start opening the throttle. And not until the actual command to the motor has reached half throttle will it switch on. There it goes, switches on. So until the motor itself has got up to half power, the timer won't run. And the only time I should be running up to sort of half power and above is, of course, during the first launch itself. So that will set the timer running. Okay, in fact, you can see it's off there. So that's how I get the timer going. Alarms, right. I think I mentioned before, my belief is once the model's airborne, you should never take your eyes off it. Not to look at the screen for any data. Jeti can speak to you everything that you need to know, either through you set up automatic alarms to tell you if something's going wrong, or through the voice output where you can manually trigger it to tell you interesting data. So let's have a look at the alarms. I've got my voltage alarm on the receiver itself. That Jeti defaults using that one. And I think that will come off the RSATs. Right, the UAQ1 and UAQ2, those are the voltages for the inputs for battery 1 and battery 2 on the central box 200. So I've set the alarms for those. I've set a temperature alarm just in case it gets baking hot inside there. The equipment is generally rated up to something like about 83, 85 degrees. So should it be a sunny day in Britain, not that we get many of them, it's pouring rain right now, but the central box and all the equipment sitting inside the canopy, a little greenhouse, could be a hot day, you never know. Capacity, this is taken off the MUI sensor for the drive motor, and therefore I want it to tell me at that capacity used. It pipes up and tells me it's time to land. Well, I'm not going to land because I've got separate batteries running the radio, but at least I know that I'm not using any more motor runs, and it will warn me a little bit before I get there that I've used that much. This one here, we have a look at it. It plays an actual voice file. Turn the volume up.
70% battery used. Land now.
As I say, in this case, I won't be landing. I just know not to use another motor run. Whereas this one, I just want it to tell me that it's used up 2000 milliamp hours so that I know I'm getting up near towards the end of my options to run the motor again. And so what we do with this one is we don't have a file. We just have it announce the current value by voice. I don't want to keep repeating actually, so I'll switch that off. So it'll just, when it gets to above 2000, i.e. 2001 milliamp hours, it will announce 2001 milliamp hours. And I know, okay, I've got maybe, a motor run or so left. Okay. What else we got? Current, that's just to give me warning of a current overload. It's an 80 amp speed controller. I'm using a Hacker A50 14L Tornado motor, which is a 400 kV motor, driving a 16 by 10 folding prop. Hacker tell me that should peak, using a 6S battery, that should peak at about 68 amps. I've got an 80 amp controller, so if the current goes above 77, it'll just give me a quick warning. And that's my alarm setup. Vario, straightforward. It's an M Vario 2. So there's the settings. Dead zone, you take a little gamble at it initially. The range is how the beeps will go. So at nothing there'll be no beep, and at 2 meters per second down will be maximum down beeping. At 4 meters per second up will give you the maximum up beeping, and these are a bit like servo travel, so it proportionates its beeping in between those two values. The dead zone I've set as 0.2 meters per second down to 0.01 meters per second up. Call that 0 really. So if the model is cruising along anywhere between those two values, the Vario will be silent. It'll have to drop below that before it starts telling me we're going down. And the reason I use the dead zone then is once I've done the test flying and experimented and got some data, I shall set the dead zone there to the normal sort of cruising rate of descent. And that means that then once the Vario goes quiet, I know I'm in nice quiet air. I've got the correct rate of descent going on. If it starts telling me I'm descending, then I know I've gone into a bit of sync because we're losing height faster than the normal cruising rate. Okay, voice output. This is where I've got the timer Flight timer set to switch GY because I like to hear my flight time by rocking the transmitter like this.
Timer 5 minutes 41 seconds.
Okay. No repeat switch. Trigger switch is set to one of my 3-position switches, spring switches.
Altitude 0 feet. Speed 0 miles per hour.
Okay, and that's set in the sensors and variables. I've got GPS, I've got an M speed, airspeed, I've got M Vario, and I've got MUI. So I don't want GPS speed and altitude. I've set it for, keep going down, the Vario relative altitude. And, no, where's M speed? There, velocity from the M speed. Okay, and single voice announcements. If I move that 3-position switch the other way, it will tell me my Q value on the receivers, like this.
Signal 100%.
And that's the way I set up all my models. Pushing that spring-loaded switch away from me always reads me Q. Pulling it towards me reads me information that's of interest to me on this model. So for different types of models, different types of things. No servo telemetry. The sensors logging setup pretty straightforward there. Displayed telemetry I've put on quite a bit. Now you might think because I'm running a Central Box 200 that a good Lua application to run would be the CB BAT monitor. And it would be, because in a double box this presents all the information very beautifully. However, these are regular voltage servos. I'm powering this through Jeti power ions, and therefore I'm going through a voltage regulator, and that's providing a constant volts output. And therefore in something like the CB BAT monitor Lua app, you couldn't choose the correct battery chemistry for that. It just wouldn't work. So I'm having to display them straightforward data from the Central Box. So usual one, antenna, a double box, that gives me my all 4 antennas and a couple of Q readings, flight timer, Central Box, input voltages, then a blank just to get me onto the second screen where I've got Central Box, the 2 capacities taken in but the 2 terminals, and the currents taken in at the 2 terminals. I've set the currents to be double-sized boxes so that I can get high and low currents. It might be of interest just to see what the maximum current that's been drawn is for the servos. Then the next screen shows the data from the MUI, the voltage, the current, the capacity. Again, current I've gone for a double box so that after the flight I can have a look at it and see just what was the maximum current drawn, rather than have to go through the data graphs and have a look at it there. Another blank to get me onto the next page where I've got data about the glider. We've got M speed from the velocity giving there from the M speed pitot system. The relative altitude, in other words, altitude above switch on point from the Vario. And this one, glide ratio, is a Lua app that I had written specially for me. It divides the speed by the Vario to give you the glide ratio, and as well as being out of curiosity and academic interest, the whole point of that is to allow me to fine-tune the glider to the best trim setting for the speed that gives you the greatest distance. You can use a Vario on its own to give you the minimum sync trim setting, but the best distance setting will be at a higher speed than that. And therefore this glide ratio constantly calculates the glide angle, or glide ratio anyway, by dividing the speed by the rate of descent. And it's a Lua app. Jeti makes a Lua app for this called Virtual Sensor, which allows you to perform all sorts of arithmetical calculations. It doesn't need to be just this one. But it only outputs onto displayed telemetry. It won't output to voice, and it won't output to logging, and that's no use for me because, as I said, I will not look down at the screen whilst I'm flying the model. I want to ping the switch and have the model speak it to me, and I want it to log it. And therefore, as time goes by over various test flights, I can determine the best trim and speed, therefore to give me the best glide ratio. And so I mentioned this, and it was written specially for me by Dave McQueenie, who's developing the GPS Triangle Racing app. And so that bit of data's on there. At the moment, it's not in the voice output, but it will be once I've got the various other things set up. I've got other things to concentrate on in the initial flights. Okay. And that gives me displayed telemetry. The app there. Okay. That's basically most of the settings done. What else is there? Well, if we have a look in Device Explorer, there's a couple of things there of interest. The M-Vario, this is the modern M-Vario 2, so it's an X-bus, so it's and properly done. So it shows up in Device Explorer. If you've got the earlier Vario, M-Vario, it's not X-bus, and you can only look at very few settings in Jeti box. But if you've got this modern one, it shows up in Device Explorer. And the one setting worth looking at is, let's see, device mode is Vario, of course. It includes a couple of expander ports, which I've set up as expanders, or made sure they're set as expanders, because I've plugged into it the M speed and the MUI from the main drive motor battery. I'm also running the GPS from RC Thoughts, which is plugged into the second expander port in the CB200. Vario settings, come down here, EX round altitude, yes, do that. That's what stops it reading out the decimal points. So if you ask it for its height and it says you're at 215.3 feet, you really don't need that 0.3 feet. So if you use the round altitude, it'll just read you 215 instead of 215.3. And into the central box 200. Now then, there is an interesting one here, telemetry min-max. You see here, there is a min-max switch you can set. And I have set that to this switch here. This does not require you to set up a function or a channel. These are command, we have a look down here, SH, clear the min-max values. It's a command switch or command function. And this cleverly works in the background of all the transmission going on. It means that if I move that switch, it will tell the central box 200, 220, 210, whatever, to zero the things like the milliamp hour count and its statistics of receiver times, yeah? And as I say, it does this without you having to set up a function or use one of your control channels. What is the result of it? Well, let's have a look. If we go back to the displayed telemetry, okay, here's screen 1, screen 2, which is showing what's going on at the central box. And here's the capacities being used and the live current. You're thinking, why is it not taking them both equally? Well, remember, I'm not using two separate batteries. I'm using a single regulator. It's a ganged output, but there could be tiny variations in the resistance of the wire or my soldering of the connections, and there could be tiny variations in the diodes or whatever it is used as the protection on the inputs of the central box. The result being at these very low idle currents, there's only 3 servos plugged in. I haven't got the wings plugged in at the moment. At these very low currents, it's enough to mean the central box is only drawing through one of its inputs. If we start wiggling things, there's not much to wiggle at the moment really. There you can see it starts drawing through the other one, and eventually capacity 1 will go up to 1 milliamp. So you get this discrepancy. And anyway, the point being, at the start of the day, if I flick the switch, I can zero these. So move the switch, it says, do you want to apply changes? I'll move the switch back, say yes, and see that it zeroed them out. And so I can go flying for the day, and I can check in this screen to see what sort of capacity has been drawn in total out of my batteries. And then after recharging them, next time I go out at the start of the day, simply operate that switch once to zero the values. Let's put a bit more milliamp hours through it. There we go. Just demonstrate it again. I move the switch, apply the changes, say yes. I'll move the switch back, and it's zeroed them out again. There we go. So I think that's everything. I hope that was of interest to you, giving you some ideas of things to do, and seen when we needed to do the programming of the wing, just how very easy it actually was. There's very little to do. Bye for now.